Hi everyone. So this week in lessons we're going to be looking at road safety and how a computer program can be used to control lights on the road in order to try and keep people safe. Now in class we're going to be using this program Flowall. So if you're at home we're going to look at how you can still do the same programming work but without using this program. So just an example, I'm going to use this thing which is called a mimic. This mimic has got inputs where we could give commands to the robot here, and it's got outputs. So today we're just going to look at the outputs. So in order to control these we're going to use something called a flow diagram. So our flow diagram always needs to begin with start so that the computer knows where it's got to go to begin with. So what I'm going to try and do with this is just get the left eye of the robot blinking on and off. So what we need to do for that is give it a command, and we're going to say turn the output, in this case the left eye, on. Now because computers work very quickly, we can't then turn it off again immediately because the computer can do that maybe hundreds of times a second. So what we need to do then is tell it to delay for 1 second. Then we can turn the output off again then. Not forgetting yet again that we need to delay so that that output can be off for 1 second, and then we can join up our flow diagram. So at the moment, if we start this, it will close the eye, it will wait for 1 second, it will put it back again there and wait for 1 second, and that's it, which is a little bit sort of useless really because it does it once and never does it again. So we're going to now use a loop which will then go from there back up to this box here. So you can see how the arrow goes just above there. So now when we press play button, you can see this working through the flow diagram, and we can see that it's just making the eye go on and off each time. If we wanted both of these to work at the same time, I have to break this program first. Let's just remove our arrows so that we can add some more boxes there. So we're going to turn the left eye on. Also, we are going to turn the right eye off because we want them to be opposites. So we can join that together. Now the computer works fast enough that there's not really any noticeable delay between it doing those two things. So then we can put our delay here. Now on this one we're going to turn the left eye off, and then we turn the right eye on so that they're working at opposites. Back to our delay, and then let's loop that back round and play this one. So we get these blinking alternately. Now the way that I've done that is actually the easiest way of doing it because we've got these separate commands, and that's fine, it will still work. A more efficient way of doing it, which means for a shorter program, is that we put the same command in each box. So we've got two commands in each of those, and we can join them together, and when we play that it's exactly the same. It's just this is a more efficient program, but when you're drawing your diagrams don't worry too much about that. Let me just start a new one here, and we'll bring up the first mimic that we're going to look at in class and that you're going to do today. So this one is for a zebra crossing. So on a zebra crossing, the lights flash on and off all the time. So they do that 24 hours a day. So what you are going to need to do for your diagram is you're going to need to begin with a start. When you're working on paper, don't worry about drawing these shapes around them. Just put your words in and put your arrows on. So we're going to start. We're going to turn the lights on. Then we're going to have to delay for 1 second. Then you're going to turn the lights off. You're going to delay for 1 second, and then you are going to loop back round to turning the lights on again. The second program that you're going to look at is this one, the school crossing patrol. So this time there are 2 lights, so top light and bottom light, and what we want is one light comes on, and as that goes off the other one comes on, so that they alternate all the way through. And then for our third task, we're going to use this traffic light. Now on the full mimic there's a set of traffic lights at the other end. We're not worried about those today, we're just going to worry about these. So the order of lights in a traffic light is, it starts at red, then it goes to red and amber. Then both of those switch off and green comes on at the same time. Next, green goes off and amber comes on immediately, and then amber goes off and we're back to red. Now we don't need to reprogram that red because we're back to the beginning of our program. For these, just put a delay of 1 second. So have the red light on for 1 second, have the red and amber on for 1 second, they go off, the green comes on for 1 second, green goes off, amber comes on for 1 second, and then we loop back round to red. So your questions are going to be on the PDF sheet. So we can see there that we've got output 1. Now when you do your diagram you can call it output 1, like turn output 1 on, or you can just call it light, that's fine. So on our second one, again we've got output 1, output 2 here, so you can call them output 1, output 2, you can call them top light, bottom light. Again, up to you, and you just need to turn them on and off, so you would say turn top light on, or turn output 1 on. And then for our traffic light, again you can call them output 3, output 2, output 1, or you can call them red, amber, green. I think the red, amber, green would probably be a little bit easier to follow. The PDF is to give you the questions. Don't print the PDF out because it's going to take a lot of ink or toner on your printer, and you can't really write on these, so you just need to write on a piece of paper. So you could type it. I'm going to do this in Word as well. So for example, for our zebra crossing, we would begin with start, then we would tell the computer turn the light on, and I'm putting on in capitals just so we can see exactly what we're doing. Then we would wait for 1, and that means wait for 1 second. Turn the light off. Wait for 1 second. And now we would then join up our flow diagram. So, example here, then we would put our arrow from start, and then we'd have another arrow there, the same there and there, and then you would have your final arrow looping back round here and going into the middle of this arrow, so that the program goes around in that loop all of the time.